All right, folks. Yesterday, I think we finished. The bell was ringing, so finished kind of haphazardly with confirming this result. We came up with the idea that if we take and express sine in terms of cosine, meaning that we are able to solve for sine, isolate sine, that's what express sine means. In terms of cosine, meaning then on the other side of the equation, the only function we see is then cosine, we get something like this. Okay? Now, what does that allow us to do? What that allows us to do is to identify what the sine of some angle is, knowing only what the cosine was. Does that make sense? So if I know, for instance, the cosine, I'm just going to tell you this right now, the cosine of 60 degrees is 1/2. Okay? Therefore, using this formula, I should be able to determine what cosine, or because of what cosine of 60 is, exactly what sine of 60 is. So if I want to find sine of 60, that is going to be, I'm going to say plus or minus for the moment, and then 1 minus cosine squared of 60. Does that make sense? Now this cosine of 60 right there, that is that right there. So we can make that substitution. So I have sine of 60 is equal to plus or minus. It's going to be 1 minus now 1/2 squared. Is that okay? So that gives me, so sine of 60 equal plus or minus 1 minus 1/4, right? Okay. So sine of 60 then is equal to plus or minus, this goes to √3 fourths, which is then plus or minus √3 over 2, correct? Okay, now, I've got plus or minus here, and that sine of 60 can't be both those. It's got to be the positive one. Sine, because 60 is in the first quadrant, right? So sine in the first quadrant is always a positive number. So √3 over 2. Now, just demonstrate with our calculator here. Square root of 3 over 2 is that number right there, right? If I type in sine of 60, anybody know why they're not the same right now? They should be the same, what we just went through. That's because my mode is in radians. So change to degrees, and we see that they are then identical, right? So identities, that is a one purpose of identities, okay? To be able to express one of my trig ratios in terms of another one, so that in the end game, I can find the value of one of my trig identities that is unknown by knowing one that is known. Okay, so the sine of 60 was unknown, cosine of 60 was known, and I can find then the sine of 60 because of that cosine. Does that make sense? Yes. Let's get through the next question and then I'll get to it. So, because I think I'm going to guess, is it because of choosing pluses and minuses? Okay. So we're going to get to that then. So one of the questions that comes throughout, and it's all mathematics, is that, how do you even know where to start? You think about geometry, there are some questions in geometry, a lot of questions in geometry, where it just gives you the image and it says, find this. You have no idea. It doesn't have any directions on what tools to use to get the ball rolling. Okay? Same thing here. Okay? A lot of trig just gives you a statement like express tangent theta in terms of sine theta, and doesn't tell you how to get the ball rolling. Okay? You are going to have to go to if you don't have them committed to memory, you're going to have to go to a table and look at your identities. Okay? Right now, our table is relatively small. This is it. That's all we know right now. Okay? Eventually, our table might be 2-3 pages long. Okay? But right now, we're going to look at this and say, okay, if they want me to express tangents in terms of sine, then I better use up here one of these relationships that has tangent and sine in it. Does that make sense? Okay. So this one does not. This one does not. This one actually does have tangent and sine in it. Okay. Indirectly, yes. Okay. And it's actually like indirect because cotangent is the reciprocal of tangent. It actually gives me this one here. Okay. That one has tangent and sine in it. This one indirectly again has tangent and sine in it. This one does not. This one not directly. Okay. This one, yeah, kind of. So some of the ones that I've crossed out, they might not directly have it there, or it might not be extremely obvious, but through a little bit of manipulation and other substitutions, you might be able to see it. But I think the blue one there is the best approach for this next question. Okay, is where to start with. Now the question, well, how do you say you could, some of those that you crossed out could work? Absolutely, it could work. We could start with that last one, 1 plus cotangent squared theta equals cosecant squared theta, and we can probably arrive at the same exact answer. Might take us 4, 5, 6 times as long, okay? And that's the thing, is that through experience, you guys been doing this for, we did it for 2 questions so far, okay? You're going on about 24 hours in terms of exposure to this. I'm going on 20 years. So I have a little bit better understanding of where to start, why to start, that kind of thing. But that foundation is basically just trying to choose the simplest looking identity that incorporates these 2 objects. Does that make sense? Okay, so that's the starting point. The next thing we're going to do is then see if we can isolate the term that is attached to the phrase express. So we chose that tangent of theta was equal to sine over cosine. Okay. Well, this says express tangent. Well, express tangent, that is another phrase for solve for tangent. And when we say solve for tangent, isn't that another phrase for isolate tangent? And is that being done already? Okay, so it's almost trivial in this choice that we came up with here. Okay, but now it says express it in terms of sine. So the only thing that can show up on the other side of the equal sign is the trig ratio sine. So cosine, that right there is a problem for us, right? So when you come across things like this, and this is going to be commonplace, is that when we choose a identity, we're probably going to have to choose ultimately multiple identities to replace things, okay? We don't want that cosine there. We got to get rid of that. So we essentially play this game over again. Now we're going to say, okay, I need to replace cosine, and when I replace it, substitution ultimately, it needs to be substituted with something that just uses sine. Does that make sense? Yes, but so what you're saying is you're saying that tangent of theta equals sine over cosine, right? And then if I multiply both sides by cosine and divide both sides by tangent, I get something like that, right? And if you do that, because that's completely correct, okay? But if you do that, you're going to get tangent of theta equals sine of theta over sine of theta tangent of theta, which when I solve that, it's just going to be tangent of theta. Does that make sense? So that wipes away, and I've expressed tangent theta now in terms of tangent theta. But that's kind of the idea we want to do. We want to choose something that involves cosine, like you did, but also involves sine. And usually, if I'm trying to get rid of cosine and replace it with sine, or get rid of sine and replace it with cosine, that's the identity that you want to start with. Because that's the identity that incorporates both the sine and the cosine, and only those two things, right? Okay. So if I want to replace cosine, then I need to take this identity here and solve for cosine. Is that all right? Let's go ahead and do that. Solving for cosine would leave me with cosine squared theta equals 1 minus sine squared theta, right? Okay, but I don't want cosine squared because that's not a direct substitution here, right? So I'm going to square root both sides, right? Now when I square root, when I introduce the square root, it's plus or minus. Now you can make that direct substitution here. So tangent of theta is equal to sine of theta divided by plus or minus 1 minus sine squared theta. Have we expressed tangent of theta? Have we gotten that by itself? In terms of sine, is sine the only trig function on the other side of the equation? Yes. Now there can be other things over there. There can be roots, there can be powers, there can be addition, subtraction, products, quotients, whatever. And you can see sine 1 time, 2 times, 20 times. Doesn't matter. But you can't see a cosine, you can't see a secant, a tangent, cotangent, or anything else. Okay? Is that doable? Okay. That is still incorrect for this question. Because they provide one more condition. Theta's in quadrant 2. And this is where, when I was in school, this is what really threw me for a loop, because I didn't fully understand what was going on. And I could do the substitution stuff. I was more, I mean, you hear me talk about this, don't be a robot. Don't be, Mr. Fay shows me how to do this step, this step, this step, and I get an answer. And I really know what that answer was. When I was in high school, I was in pre-calculus, and I was that way. Didn't really fully understand what was going on. And I missed out on not only information, but missed out on points and getting things correct, because this, even though I've done everything right so far, is not answering this question. Okay? This is saying that essentially, if theta is between 0 and 360, you're going to either have tangent of theta equaling to sine divided by a positive square root, or you're going to have sine divided by a negative square root. Okay? We got to think about this. Now, quadrant 2 then. So what I'm trying to get at is, when I was in school, I didn't know what that meant, so I ignored it. Sometimes I got it right, sometimes I didn't get it right. Okay? You can't, if they're giving you that information, you cannot ignore it. Okay? Well, think about this. What are we trying to solve for? Tangent. We want these two things to be equivalent. We know tangent of theta, okay, so theta is in the second quadrant. We know tangent in the second quadrant, because of all students take calculus, tangent in Q2 is negative. Okay, so that number should be negative. So then we need to look at this and say, okay, well, how do we then make this number on the right-hand side negative? And you have to be cautious. You can't just say, oh, well, I got to choose the negative radical. Because this contributes a sign, and that's as well. Okay? In the second quadrant, this numerator would be what kind of number? It'd be positive. Okay? So numerator is going to be positive. So then to make the denominator, what do I have to make the denominator so that this quotient becomes negative? It has to be negative. Okay? Where that would not have been the case if, for whatever reason, like we were doing like cosine up top. Well, cosine inside quadrant is negative, right? And if I wanted this quotient to be negative, then I would have to choose the positive radical, right? Okay, so you have to look, you can't just look at the plus or minus and decide which you choose based off that. You got to look at the quotient. Yes. Yeah, you can do that. So you want to take that negative out? So you're saying like do this. Yeah, that'll work. Let's talk about y though. Let's look at this real quick. We should be able, so what this is saying is if I want to know the tangent of, let's say, we're in second quadrant, so let's say I want to know the tangent of 120 degrees. And I don't know that. But I know that the sine of 120 degrees is radical 3 over 2. I should be able to plug in radical 3 over 2 right here, radical 3 over 2 right here, divide those, and then that ratio will be the tangent of 120. So let's let Desmos do this for us. First thing, make sure I'm in our degrees. Okay, we can do these in radians as well. I just think for our purposes of checking, it makes it easier to do it in degrees. All right, so what I'm going to do is I'm going to type in tangent. Now you have to choose a variable. I'm just going to use t. I don't know if, you can probably search through here and see if there's a theta variable. There is, but I don't know what that's going to let me. I say tangent of theta. It doesn't let me create a slider for theta. Does that make sense? And I want a slider here. So I'm just going to say t. I'm then going to type in what we just came up with. Sine of t divided by the square root of 1 minus sine squared of t. All right. Now, we were in quadrant 2. So the nice thing about Desmos is I can click on this and basically define that I want to be stuck between 90 and 180 degrees. Does that make sense? Okay. And now everything I choose here, you see the t value is oscillating. Everything I choose will be a second degree angle. Well, what is happening when I choose, I said 120 degrees, and I can actually type in 120 as well. Just highlight that and type in 120. What are we seeing between these two numbers? They're opposites, right? So how do I fix that? I choose that negative, right? And what Jimin was saying was, well, can I get the same result by just taking a negative out in front of the whole thing? Absolutely. Does that kind of make sense to us? Okay. Again, it's going to be early on. It's going to be something that's frustrating. Okay. Don't let frustration be something that shuts you down, but let it be something that motivates you. Okay. Through teaching this and working with students through the past, frustration, a lot of times people just say, well, I don't get this. I'm not gonna worry about it. I'm not gonna get better at it, and they ignore it. And that comes back to haunt them in the next chapter, and in the next chapter, and in the next chapter, and then again in the next chapter. Okay? If you can understand these relationships and understand here in a little bit when that was one technique for demonstrating a check on our solution here. If you can check yourself with this stuff, that demonstrates that you know this stuff really well. Okay? For the last class, when if it takes you 40 minutes to do your homework and then teacher says check it, and that's an extra maybe 20 minutes, now my homework's an hour long, right? And maybe I don't want to use an hour to do my math homework. But if you check it, and it does take you that hour that first time, the next time you do that assignment, there's no way it should take you 40 minutes. Does that make sense? Because you reinforce the concepts when you check your work, and you increase your abilities, you increase your skills dramatically, and the next time it might only take you 20 minutes to do the homework. And you might not even have to check it because you're guaranteeing yourself that you know what you're doing. Okay, so every time we go over through something in class, we're going to check them. Okay. So this is the exact same thing that was that first example, but they are expressing it a little bit different and they're writing it a little bit differently. It says write the first trigonometric function in terms of the second for theta in the given quadrant. So this here, as written the way that we've seen in the notes, would say express cosine theta in terms of sine theta, where theta is in Q4. So then you're gonna solve. You're gonna get cosine by itself, and then on the other side of the equal sign, the only thing you're gonna be able to see is sine. Does that make sense? Does that clarify things? Let's see here. I'd like to get through. So this next question is it's actually going to be, these next two questions are they're not extremely difficult. We've already kind of seen something similar to this when we first worked with sine, cosine, and tangent. But this is a common reoccurring question throughout the course. I would say that every time we learn a new relationship between angles, maybe a half angle, a double angle, some difference, that kind of thing, they're going to ask the question like this. And the structure that we do this one will be very similar to the structure that we do these other ones. Okay? So, and there should be a built-in check to kind of make sense of all this. Again, you should be able to do this by following, we do enough examples, following my lead, and being that calculator or that robot. Okay? But I don't want that. I want us to be able to understand what they're doing here. They say if tangent of theta equals 2/3 and theta is in quadrant 3. So in quadrant 3, that is our theta, correct? Okay. Now, theta then is going to, if it terminates in quadrant 3, it's going to produce for us that red right triangle. You agree with that? And this red angle right here is ultimately our reference angle. And we could put that reference angle back in the first quadrant if we want to, like we did when we were working with reference angles. Okay? I'm going to leave it here, though, because if I leave it here, I think it's going to generate my answers a little bit quicker and a little bit more kind of intuitively. Okay? They tell us that tangent of theta is 2/3. Well, remember how tangent of theta is defined. Tangent of theta is your y divided by x, right? Okay? So that 2 is the y, or the opposite side, if you want to think about it that way, of this red angle. So that's 2. And the 3 is the adjacent side. Okay? Now, here's the issue. When I divide them, I get 2/3. But individually, neither of those are 3 or 2. They're -3 and -2. Okay? And that brings us into discussion, and I know we've done this in the past. I did this when I was a student. Get my test back, do Math Excel, whatever, and it says the answer was 2/3, and it should have been -2/3. And when I go to the teacher, I say, I just forgot my negative. Can I get a point back? That should never have ever occurred, okay, because -2/3 is completely different than +2/3. But a lot of times I and other teachers would have given you those points back, right? We would say as a human mistake, human error. Amber Alert, same one. Now in trig, like if the answer is negative 2/3 and you write 2/3, I'm going to count that as wrong because positive 2/3 would tell me that you're working in quadrant 1 and not quadrant 3. Does that make sense? And that's a completely different understanding on your part for what the problem is asking. So that is something that we need to be paying attention to, even if it is a legit, but I can't tell if it's a legitimate human error that you just forgot the negative. Like, there's no way that I can decipher unless I was watching you do all the work. Does that make sense? Okay. Now, if you've got the picture drawn out, you've got -2, -3 here, and you go to your answer and you miss the negative there, maybe I could justify that. But otherwise, it's going to be hard to do that. Okay. So just be cautious of that. If that's the case, do we have the ability to find the hypotenuse here? Okay. So -2 squared plus -3 squared. We take the square root of that, right? So square root of 13. All right, so now when it asks for finding cosine of theta, because I left the picture in the third quadrant, all I'm really asking for is the adjacent side of this triangle divided by the hypotenuse. So it's -3 divided by root 13. -3 divided by root 13. If you were a person that says, okay, I did all this work, but I took, when I found theta and it gave me this little triangle here, I took that triangle, put it back up here in the first quadrant, and you called that theta, or theta bar, whatever you want to do, and I called that 3, and I called that 2, and that's root 13. And then you ask for cosine of theta, and you say, well, it's 3 over 13, 3 over root 13, okay? Is that the cosine of theta for this particular problem? If I'm in quadrant, I'm supposed to be in quadrant 3. It's the wrong sign, right? So then you would go and say, okay, well, all students take calculus, tangent's positive there, it's the only one positive, so this must be negative. Does that make sense? So you could do it in quadrant 1 as a reference angle, but then you got to add that last step of saying, okay, they want a cosine to be in the third quadrant, should it be positive or negative? Where if I just leave the whole picture in the third quadrant, it incorporates that on its own. All right, so these problems, especially later on in the course, get very involved, get very time consuming, and it would be nice to have the ability to check it to make sure that we did all that work correctly. So I want to show you how you check these types of things. You could, and I'm not a big stickler on that at the moment, but if you want to rationalize that denominator, that's fine. Okay? Mari? Okay, so so the question is, if tangent of theta is equal to sine of theta over cosine of theta, right? Okay. This 2/3, because remember here, sine of theta is y over r, and cosine is x over r, right? So then we would have to say that 2, so sine of theta is, so you're saying that this y over r would be 2, and x over r would be 3. Does that make sense? You could do this, so then I would have y equals 2r and x equals 3r. We would need to be able to solve this for r to do that. Does that make sense? And it would still lead you to, if you, because it's a system of equations now with those variables, it would lead you eventually to radical 13, I believe, if we did it that way. But we don't do that because there's easier ways to find that R, and we need that R. If this was a I don't want to say it. Well, we might come back to that later on when we talk about the unit circle. But right now, because we don't know that root 13, we don't do that. If it was a 1, it would be kind of trivial, and we could probably do that. Or I know we could do that, and we'll get there in chapter 6, though. Good question. Let's check this, though. Okay, but in order to check this, we need to understand what inverses are. You guys know what inverses are from college algebra, right? Okay, so, and this we'll talk directly about inverses of trig functions tomorrow. But if I have a function, let's just say f of a equals b. Which one of those is referred to as your input? Okay, so that's your input. And b would be then your output, right? Okay. Then when I go, and so that's going to generate ordered pairs a comma b, right? If I have the inverse, okay, using how the function was defined, what would be the input for the inverse? B, and the output would be A. Remember that from college algebra, yes? Okay. Sine function, okay, that is the input, right? That is the input, and that is an angle measurement. So it might be a degree or it might be a radian, okay? The output, so sine would be the output is y over r. Output is a ratio. Does that make sense to everybody? Okay. So when we do the inverse, this is how we would write, this is one of the ways we write the inverse for the sine. Okay. What is going to go, if we're using this logic right there, okay, what will be this thing here? Okay, so y over r goes there, or your ratio becomes your input for the sine inverse. What's the output going to be then? Theta. Output is an angle. Okay, so let's demonstrate this real quick. Let's use Desmos again. Make sure I'm in degrees. Okay, so if I say sine of 30, what should it give me back? 1/2, right? Okay, that's what we've been talking about for a couple days now. Now, if I go sine inverse, and now I type in my ratio, does it give 30 back? Okay, so let's use that feature to help us out here. Okay, this problem right now says that tangent of theta is 2/3. Now, when we talk about inverses, if I just talk about the sine function for now, it's easier to see in radians. If I see the sine function right now, it's a function because it passes the vertical line test, right? Does it pass the horizontal line test? No, so it's not 1-to-1. So if it's not 1-to-1, it does not have an inverse, right? But if we shorten it, and I don't remember how to do this on Desmos, I didn't think that would work. Maybe I just put in parentheses here. Well, I'll figure it out. But basically what we want to do is we just want to we want to be able to cut up, and we'll talk about this in a whole other section, a whole other chapter. Basically, we want to chop off part of this curve so that it does pass the horizontal line test, right? Remember doing that with quadratic, with x squared? If we just look at the first quadrant, then it passes the horizontal line test. So we do the same thing with sine. So what I'm trying to say there is that when we use these inverses in these problems, they aren't going to give us directly the theta in the third quadrant. Okay? So when I go, they're telling me that tangent of theta equals 2/3. That means the opposite divided by the adjacent is 2 or 3. That's my ratio, right? So if I go tangent inverse of 2/3, it should give me back, I'll do this in degrees, should give me back 33.7 degrees. Is that okay? Now, what that means then is that our picture right here why? All right, there you go. So our picture, this 33.7 that our calculator is giving back right there is that angle. Does that make sense? What we really want, remember, theta had to be in the third quadrant, correct? So if I take the opposite ray of that and put it in the third quadrant, this angle here is also 33.7. Does that make sense? So now, help me out here. What would, if I'm looking at theta, how big would be theta if I stopped right there? 180. How big would be theta then? Or what do I need to do with that 180 to get that theta? 180 plus 33.7. Does that make sense, everybody? So, when I add 180 to this, I get that number right there. So I'm just going to call that T. Define that as T. Just to check to see if I did this right, if I type in tangent of T, does it give me back 2/3? Yeah. Okay. So I know that the theta in the problem, even though at the beginning of the problem we didn't know it, but now we know because of inverses, we know what that angle in the third quadrant that they were actually talking about. 213.690067.526. Okay. So that is the angle here for cosine as well. Does that make sense? So let's type in cosine of t. Gives me that number there. Is that okay? So that's the cosine of 213.690067.526. Well, how does that help me check to see what we've done right? Or what we've done is right? Isn't this t, or the theta, the 213? So it's equal to this, right? Let's take -3 divided by square root of 13. What do you recognize about those two numbers? They're the same. Okay? One of those numbers can be found using essentially rounded values like the 213 degrees. This one, we found that exact result using our trig ratios. Does that make sense? Okay. So questions in which we want to check ourselves for some unknown theta in some quadrant, we should, because of inverses, have the ability, when we're done, to actually determine what that unknown theta was. Okay. And because of that, then we could check to see if we did everything here correctly. We'll start this one tomorrow. Tomorrow, my plan is to get through example 7. That won't take but maybe 5-6 minutes. We're going to skip this area of triangle stuff. There should not be any questions in 5.3 over that. And then we'll get into 5.4. But before we get into 5.4 tomorrow, I would like to open up your homework, because the homework for 5.3 is due tomorrow evening, and answer any questions that we might have on that. Okay, I'm anticipating maybe some of those questions towards the end that ask you to express one function in terms of another. Again, those are questions that I think are very important right now because of how much they get used later on. Okay, so the sooner we can learn that stuff and understand that stuff, the better off we'll be.